This lesson is about cube roots, which is very similar to what we did with square roots, same concept, only now we're talking about cube roots. So let me explain what a cube root is by giving you a question/example. What number, when multiplied by itself, then multiplied by itself again, equals 27? So what number used 3 times is 27? And the answer is 3. Now, unlike when we did square roots, we would say 3 add -3, but for this case, we can't say -3 because if you remember, -3 times -3 times -3 would give you -27, and that's not what we want. So cube roots only have one answer, whereas square roots have 2. So, as I said earlier, this concept is called a cube root because when you use it as a factor 3 times, you get the original number. So we would say 3 is the cube root of 27, or what is the cube root of 27, and the answer would be 3. And similar to perfect squares with square roots, we do have perfect cubes, and these are numbers that when you take the cube root, you get a friendly integer, kind of like square roots. So the symbol looks very similar, but instead of just the regular like check mark thing, we have a 3 inside to show the reader that we're not talking about just the square root. We want to use it 3 times, and so you have to look for that little 3, and that's called the cube root symbol. So let's practice finding some cube roots. So we're looking for the cube root of 8 means what number used 3 times equals 8. So you guess and check with your calculator, 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3, right? So you figure out that it actually is the number 2, because 2 times 2 is 4, times 2 is 8. So the answer is 2. The cube root of 8 is 2. We do the same thing for letter B. What number used 3 times equals -27? Well, that's actually my example from earlier, right? It would be -3, because -3 times -3 is +9, and then times -3 is -27. So we would say the answer is -3. Similar to when we did square roots, we're going to take the cube root of each part. So we're going to do the cube root of 1 over the cube root of 64. So what number times itself, use it 3 times, gives you 1, and that's 1, because 1 times 1 times 1 is 1. And the cube root of 64 is what number used 3 times is 64. So you play around with your calculator, and it's 4. So the answer would be 1/4. There is a cube root button on your calculator. It makes the math really quick. It's very similar to how you use the square root button. So take a moment to look around your calculator to see if you have the cube root key. It makes life a lot easier. Example 2 is using GEMDAS, or as we now call it, GERMDAS, because of radicals. These are considered radicals because it has the check mark thing. So we're doing 2 times the cube root of -216. So you follow your order of operations, and the first thing that we hit is the radical, then we'll multiply. So it's 2 times the cube root of -216. So what number used 3 times is -216? Guess and check on your calculator. It's going to be -6. So it's 2 times -6, which is -12. For the second example, letter B, we're going to do our grouping symbols first. So we're going to find the cube root of 125 and then raise it to the 3rd power. You might know where we're going with this, and if you do, that's great. If you don't, just follow along. So we want to find the cube root of 125. So we're saying what number used 3 times equals 125. So that's the number 5. So the next step is going to be 5 to the 3rd power. and 5 to the third is 125. So just like when we did square roots and we learned that squaring is the inverse of square root, cubing is the inverse of cube root, so they undo each other in the same way. I would like you to do the practice section, give it a shot, okay? If you get any wrong, that's okay. Fix it when I reveal the answers. And so pause the video now. Alright, here's what I got. I got 1, 7, then for this one, I broke it apart, and remember when you break a fraction apart, you just give the negative sign to the numerator, so this gave me negative 3 over 10. This, I had to do the radical first because of germ DOS, so I did the cube root of 8, which is 2, and then I did 4 times 2, which is 8. Remember, order of operations, you multiply before you subtract, and so then I got 10. And for this one, you see I recognize that the cube root and the cube are inverses, so I just crossed them out, and it left me with negative 64. You could have also done the cube root of negative 64, gotten negative 4, then raised that to the third power. It would bring you back to negative 64. So either way, doesn't matter. It just shortcuts a little if you notice that. And then when I added them, I got negative 21. We're going to take our idea of cube roots being the inverse of cubes and solve some equations. So in letter A, you notice that the x is kind of by itself, with the exception of that it's being raised to the third power. So if I want to get rid of that exponent, I'm going to do the inverse, which is do the cube root on both sides. So I'm going to cube root, and then that cancels out the exponent, and I just have x. And then the cube root of 216, we actually did that a little earlier. It's going to be positive 6. I think our example from earlier was negative 6, but that was because it was negative 216. So you get 6. And remember, for these, you don't get 2 answers. Cube roots, you only get 1. Square roots, you would get 2. For letter B, I can't just do the cube root right away, because if you think of germ DOS going backwards, the first thing I need to get rid of is actually the multiplication. So I'm being multiplied by a fraction. So the way that you inverse a fraction is you multiply by the reciprocal. So that cancels out the fraction. So I just get n to the third. And then over on the side, I'll get negative 8. You can write negative 8 over 1, but, you know, I'm just going to write negative 8. So now I'm going to cube root both sides to make the exponent go away. So these cancel out. I just have n, and the cube root of negative 8 is going to be negative 2, because negative 2 to the third power, or negative 2 times negative 2 times negative 2 is negative 8. So there's my answer for letter B. Alright, in our last example, example 4, they tell us that we have a baseball display case made of plastic, and it wants to know how many square inches of plastic are used to make the case. They give us a little plan. They tell us to do step 1, which is use the formula for the volume of a cube, since the case is in the shape of a cube. But that's not what they want. They don't want the volume of this cube. They actually give us the volume down in the picture. What they want us to do is they want us to find the surface area. How many square inches of plastic are used to cover up this rectangle, or I'm sorry, this baseball. So we have to find the area of one side, and then since it's a cube, luckily we can just multiply by 6. So that's where this formula comes from, the formula for surface area. So step 1 tells us to take our volume and plug it into the formula. So if the formula is v equals s to the third, I can plug in 125 equals s to the third, and then I'll take the cube root of both sides to get the s by itself. That way I can find the length of each side. So the cube root of 125, what number used 3 times is 125, and that's going to be 5. So the side is 5 inches. So now if you think back to the picture, what we have to do is we have to find the area of this square, and then we have to multiply by 6. That's where this formula comes from. So let's take our formula, which is s equals 6s squared, and now instead of s, I'm going to plug in 5 right there. I'm not going to plug it in for the big S because that's the total surface area. I'm plugging in for the side. So I get that the big S surface area equals 6 times 5 squared. So big S surface area equals 6 times 25, and 6 times 25 is 150. So it's 150 square inches of plastic used to cover this baseball. Alright, if you have any questions, write them down and ask me when you talk to me next.